Okay, going through the Year 12 January assessment for 2022. Just going to blitz through it and try and get through as fast as I can. Please just check the questions which you got wrong and correct any mistakes. If you have any further questions, please feel free to contact me directly. Okay, so question number 1. Figure 1 shows a graph of y equals f of x, which has a turning points at A, which is minus 2, 0, and B, which is 2, 6. We're not given the equation of the curve, but that's not important for this question. State the coordinates of the images of A and B under the following transformations. So you need to link, well, what does replacing x with x plus 2 do to the curve? Well, that's going to translate the curve in the negative x direction by 2. So the point A, or the image of A, which I'm going to call A primed, is minus 4, 0. And the image of B is going to be 0, 6. You get 1 mark for each correct pair of coordinates there. This one here, instead of adding 2 to the x, you're adding 2 to the f. So that's going to move all of the points up. So A primed, therefore, is going to be the point minus 2, 2. And B primed is going to be the point 2, 8. And finally, replacing x with x on 2. Well, that's going to be a stretch in the x direction by a scale factor of 1 over a half, which is a scale factor of 2. So therefore, all of the x coordinates are going to double. So A primed for this one is going to be minus 4, 0. It's actually the same image as it would have been for part A. However, image of B is going to be different because it's been stretched, it's not translated. So that's going to be 4, 6. Okay, 1 mark for each correct pair of coordinates. Okay, question number 2. Given that y equals 64x to the power 6, express each of the following in terms of kx to the n, where k and n are constants to be found. So y to the power of 2/3. So part A, I'm just going to plug in y is 64x to the 6, 64x to the power 6, to the power of 2/3. So the 2/3 is going to affect the 64 and the x to the 6. So 64 to the 2/3, you could use a calculator if you wanted, but you'll come to the answer of 16. And the reason for that is because you're going to cube root it and then square it. Or you could square it and then cube root it. But I'd recommend cube rooting 64 first. And then the x to the 6 to the power 2/3, well, your power and indices, so you times the powers. So that's going to be x to the power 4. Okay, 1 mark for the 16, 1 mark for the 4. Part B, y to the minus 0.5. So it's again 64x to the 6. But this time to the power 0.5. That's 1 over the square root of 64, which is an 1/8. Okay, square root of 64 is 8, but because of the negative, it's 1 over. And then that's going to be x to the minus 3. Again, power indices times. 1 mark for the 1/8, 1 mark for the minus 3. All right, question number 3. Given that theta is an obtuse angle, and sine theta equals 1/4, find the exact value of tan theta. Well, what we can do here is we can draw in a right angled triangle, you get theta. Sine of theta is 1/4, so sine by SOHCAHTOA is opposite over hypotenuse. So a bit of Pythagoras will tell you that is root 15. That means tan theta is 1 over root 15. However, that would be true if theta is acute, but we're told theta is obtuse. So that means tan of theta is negative. So therefore, tan of theta is minus 1 over root 15, which if you left it like that, you would get full credit. However, mathematically, we should not have a surd on the bottom if we can help it. So it should be left as minus root 15 on 15. Question number 4. Sketch on the same set of axes the graphs of y equals cos of x and y equals cos of 2x, or sorry, 2 theta, for theta between 0 and 360, labelling each graph clearly. Okay, so I've got a bit of blank paper here, so I expect the graph to be drawn there. I have drawn negative theta, but actually I only need the positive theta. It's a y-axis. Now, between 0 and 360, cos of theta is going to have 1 complete cycle. So it's going to go from the 1 that it starts at, it's going to be halfway down here at the minus 1, and then it's going to finish up here at the 1, and it's just going to look like a sine wave. Something like that. Close enough. And label it. It says to label the graph. So this is cos of theta. Cos of 2 theta, replacing theta with 2 theta, that's going to squash the whole graph by a scale factor of 2, which means instead of having 1 oscillation, it's going to have 2 oscillations. So it's going to have completed a cycle By the time it gets to here, it's going to be negative at this point and negative at this point. And again, we can just draw the graph. Something like that. And don't forget to label this one cos of 2 theta. Okay, just put some labels on the axes. So I'm going to put 360 there. I'm going to put 180 there. At that point there, it's 270. And that point there is 90. And then 1 and minus 1 on the vertical axis. Okay, and that'll be enough for a sketch. You do need to label clearly which graph is which. Okay, and I've done that here by putting the definitions next to each of the curves. And you did need to label the x-axis to get full credit. Part B, solve the equation cos of 2 theta is minus 0.5. Well, if we look at the first part of this, part A, then we can see if I draw a line at minus 0.5, it's going to cross this 2 theta curve in 4 places. So we're going to look for 4 solutions to this equation. So B, I'm going to say 2 theta equals arc cos of minus 0.5. If you inverse cos minus 0.5, you will get, use my calculator here. It's one of those ones I should know, but hey ho. Right, minus 0.5. Get 120 degrees. So if I do 360 minus that, I'll also get that 2 theta will be equal to 240 degrees. I also need to add 360 to each of those. So it could be 480 degrees, or it could be 600 degrees. And if I half each of those, then I'll get then that theta is either 60, 120, 240, or 300 degrees, and all of those will fall in range. And you can check those answers by plugging them back into the equation. You should get minus 0.5 out in each case. Question number 5. Write x squared minus 9x plus 8 in the form x minus a all squared plus b. This is called completed square form. So for completed square form, the coefficient of x squared is already 1, so we don't need to change anything there. A is half the coefficient of b, so that's going to be x minus 4.5 squared. And what that's going to do is it's going to produce a positive value, which I don't want, okay, plus 4.5 squared. So I need to subtract the 4.5 squared from that. And then, of course, I've got my plus 8. So this bit here, that is the same as the first 2 terms, the x squared minus 9x. And I've minus the 4.5 squared because I get a plus 4.5 squared from there. And then we can neaten that up to give you x minus 4.5 all squared. And then you get minus 12.25. So A is 4.5 and B is minus 12.25. Part B, state the coordinates of the minimum point. Well, the minimum is going to occur when x is 4.5. Oops. X is 4.5 because the lowest that this can be is 0 because it's a number that's been squared, and that occurs when it is 0, x is 4.5. And if x is 4.5, then this will be minus 12.5. Sorry, 12.25. So therefore, that is the coordinate of the minimum. Part C, find the coordinates of where the graph crosses the coordinate axes and sketch the graph. Okay, so it crosses the coordinate axis. Well, the easiest one to check is when x is 0, and that's when y is 8, because there x is 0, and y is 8. The other one is when x is, when y is 0, and we can factorise that. So we can factorise this into x minus 8 and x minus 1. Okay, this quadratic factorises into this. So that is 0 when either x is 1 or when x is 8. Okay, so those are the 3 points where it crosses the coordinate axes. It also requests me to sketch the curve. So there's a blank bit of paper over here which you can use to sketch. If you did it on a line paper, it's not a problem. It's a positive parabola, so something like that. Its 2 roots are both positive, so therefore the y-axis needs to be over here somewhere. There's my y-axis, there's my x-axis. It crosses at 1 and 8, and it crosses the y-axis at, that was 8 as well. That's enough for the sketch, and you can get full credit for that. However, we have found the coordinates of the minimum, so therefore we might as well just pop on the coordinates of the minimum. There you go. Back to question 6. Solve this trigonometric equation. 6 cos squared theta equals 5 plus sine of theta, and we'll ask to solve that between theta values of minus 180 and 180. So first thing I notice is I've got a cos and a sine present. However, this is a cos squared, so I can use the identity that cos squared plus sine squared is 1 to get rid of the cos squared. And that will give me that 6 into 1 minus sine squared is equal to 5 plus sine. You can use C for cos and S for sine in your working, that's not a problem. Rearranging that, I'll get 6 sine squared, if I bring this over to the other side, plus a sine, and then I've got 5 minus 6 is minus 1, equals 0. I can factorise that, that'll be 3 sine minus 1, and 2 sine plus 1, equals 0. So either sine of theta equals a third, or sine of theta equals minus a half. Okay, those are the two solutions for sine of theta, and then I can go ahead and solve those. It doesn't give a particular degree of accuracy, it doesn't request one, so therefore 3 sig fig is standard. So I'm going to use that. So if I inverse sine a third, my calculator will give me that it's 19.5 to 3 sig fig, and if I do 180 minus that, I'll get the next solution, and that's going to be 161 to 3 sig fig. And this one here, if I inverse sine minus a half, I'll get minus 30. That is in range, so that's fine. So minus 30. And then I also need to do 180 minus that, but that'll give me 210. That's out of range. But if I do 210 minus the 360, that'll give me another solution of minus 150. So those are the 4 solutions to the equation. You can check all 4 of those, run them back through the equation to make sure that they are all satisfy it. Question 7. L1 is parallel to the line x plus y equals 5 and passes through the point A, which is 5, 8. Part A, find the equation of the line L1 in the form ax plus by plus c equals 0. Okay, because it's parallel, it's got the same gradient, which means that, well, the gradient of this is minus 1, if I were to minus the x from both sides. So the gradient of it must be minus 1. And that means that A and B must be the same value. So I'm actually going to stick with x plus y plus something equals 0. And I want it to go through 5, 8. So if I plug in x is 5 and y is 8, this equation should be satisfied. So therefore that needs to be minus 13 to make that 0. That's the equation. If you did a few more steps, it's not a problem, but you have to arrive at that answer. You could have that times by minus 1, i.e. minus x minus y plus 13 equals 0, and still get full credit. Part B. Find the coordinates of the point of intersection of L1 and L2, and we're told L2 has this equation here. So this is for 3 marks. What we need to do here is we need to solve these 2 equations simultaneously. If ever you're asked to find an intersection of 2 lines or 2 curves, simultaneous equations, straight away. So y is 13 minus x, so I get 13 minus x for L1, and that needs to equal 2x plus 4, which is the equation for L2. So it's eliminated y for both of those. I'm going to add x and subtract 4. That tells me that 9 is equal to 3x, which tells me that x is 3. Okay, it's asked for the coordinates of the point of intersection, so I need the y coordinate as well. If I plug in x is 3 into here, I'll get that y must be 10. And just check that with the other equation. Okay, if I plug in x is 3 into here, 2 times 3 is 6, plus 4 is 10. So it satisfies that point as well. Part C. Find the coordinates of intersection of the line L2 with the curve y equals x squared minus 2x minus 1. The good news about this question is even if you got the line L1 wrong in part A, you can still get full credit for this one because you're given the equation of the line L2. Again, it's an intersection, so therefore we are looking for solving these 2 equations simultaneously. So y equals 2x plus 4, and y equals x squared minus 2x minus 1. Therefore, 2x plus 4 equals x squared minus 2x minus 1. That gives us a quadratic x squared minus 4x minus 3 equals 0. A number of different ways you can solve it. You can use the quadratic formula, you can complete the square, you can factorise, it really doesn't matter. I'm going to say it's x minus, oh, no, it's minus 5, apologies. Minus 1 minus 4 is minus 5. So it's going to be x minus 5 and x plus 1 equals 0. So that tells me that x is either 5 or minus 1. But I want the coordinates, again it's asked for the coordinates, so therefore I need to plug that back into one of those to find the y. It's going to plug it into the linear, because that's a bit easier. If x is 5, then y is 14, and if x is minus 1, then y is 2. You could check that with a quadratic as well in an exam setting, but those are the correct coordinates. Question number 8. Okay, points A and B are with coordinates minus 1, 4 and 7, 8 respectively. Find the coordinates of the midpoint M of AB. So M is the midpoint of AB, so that's this point here. So the midpoint of 2 points, you just add the x coordinates, add the y coordinates, and divide by 2. So M, that's the part A, M is 7 plus minus 1, which is 6, divided by 2, which is 3. And in the y, it's 8 plus 4, which is 12, divided by 2 is 6. So the point M has coordinates 3, 6, which you would get 1 mark for 3 and 1 mark for 6. Part B. Show that the equation of the perpendicular bisector of AB is given by this equation here. You cannot use this equation in your answer. Okay, it's a show that question, which means you must arrive at that fact. You cannot use that fact to show that fact. You must arrive at that fact. So part B, we want the gradient of AB, which is difference in y, so it's 8 minus 4 divided by difference in x, which is 7, minus 1. So we're going to get 4 over 8, which is half. So that's the gradient of AB. I'm asked about the perpendicular bisector, so therefore the gradient of the perpendicular bisector is the negative reciprocal of that, which is minus 2. So that's the gradient I want. A bisector will go through the midpoint, so it needs to go through M, so it needs to go through the point 3, 6. So it goes through the point 3, 6 and has the gradient minus 2. Therefore, y minus 6 equals minus 2 into x minus 3. If you tidy that up, you will arrive at the correct answer. Now, the correct answer is in the question, so you need to be a little bit careful as to how you display your detail here. So I'm just going to say y equals minus 2x plus 6 plus 6. So y plus 2x equals 12. And that's enough there to show that you have gone through the working yourself. If you go from this straight to this, you could be accused of fudging the result. So you would lose marks. Just be careful with show that questions. Those are questions where the answer is in the question. Okay, part C. Part C says find the area of the triangle bounded by the line AB, the perpendicular bisector of AB, and the y-axis as shown shaded in figure 8. So for part C, we're looking for this region here. So I want this distance, which is the x-coordinate of my midpoint, which is 3. I also want this distance here, so I need to find where AB crosses the x-axis, that's like the y-axis, and where the perpendicular bisector crosses the y-axis. Now the perpendicular bisector crosses the y-axis when when y is 12, because when x is 0, I get y is 12. And you're actually given that implicitly up here. When x is 0, y is 12. So that point there is 12. This point here, well, we've already worked out that the line AB has a gradient of a half. So I need to move 1 in the x direction to go from A to the y-axis. So therefore I need to move half in the y direction. So that's 4.5 is that point there. So that distance there is 12 minus 4.5, which is 7.5. And now it's just the area of a triangle. So it's that times the perpendicular height. So 7.5 times 3 and divided by 2. So the area is 7.5 times 3 divided by 2. 11.25. Okay, and finally part D, a little cheeky part down here underneath. The circle C has its centre on the x-axis and passes through A and B. Calculate the equation of the circle C. Well, if a circle is going to pass through 2 points, then that means its centre must be on the perpendicular bisector. Now we're told the centre is on the x-axis, so that is making the link that we need to know when the perpendicular bisector crosses the x-axis, and that will be the centre of the circle. So I'm looking for this point here. So this crosses the x-axis when y is 0, which means x is 6. So the centre of the circle then is 6, 0. The other thing we need to find is the radius, and that is going to be the distance either from the centre to A or the centre to B. Both the same distance, and the distance comes out to be root 65. Okay, so difference in y is 8, difference in x is 1. So root 64 plus 1 is root 65. This way it's 7, so it's root 49 plus 4, root 16. 49 plus 16 is again 65, so that's the same distance. So that gives us the radius of the circle. So therefore my answer to D is x minus 6 squared plus y squared equals root 65 squared, which is 65. And that's the answer to the question. 3 marks for that. All right, question number 9. Bit of cosine rule for this one. The course of a yacht race is a triangle, as shown in figure 12A. The yacht starts at A, then travels to B, then to C, and then finally back to A. Calculate the total length of the course for this race. So just look at this as a triangle. We need to find this length here. Once we found that length, then the race length is the sum of those 3 edges. So to find this length, we're going to need to use the cosine rule because we're dealing with 3 edges and 1 angle. And I'm going to say that the length BC is going to be equal to the square root of 302 squared plus 348 squared minus 2 times 302 times 348 times the cosine of 72. Okay, that's just applying the cosine rule. You're given the cosine rule formula in the formula booklet. If you plug all that through the calculator, you will get that BC is the length 383.868 blah 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 meters. It appears these have been rounded to the nearest meter, so therefore we should really use this as 384 meters. If you add those 3 then together to get the total distance, then we arrive at 1,034 meters is the total length of the race. Okay, that's to the nearest meter based on the information that we have. 9 part B is very similar in the sense that it is another race and we use trigonometry to find the length of it. But this time, instead of being a triangle, it is now an arc of a circle plus a chord. Now the arc of a circle is going to be a portion of the full radius, the full circumference. So let's work out the ratio. Well, this angle here is going to be 360 minus 136, which is 224 degrees. So therefore the arc length is going to be 2 pi r, which is the whole circumference, times this ratio, which is 224 over 360. We only want a portion of the full circumference, and it's 224 360ths. And if you plug that through, that comes out to be 469.14 blah 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 meters. And then we also need this chord length here. So what we can do is we can consider this triangle. It's an isosceles triangle, and we can use the cosine rule on it. So I'm going to say the chord is going to be equal to the square root of 120 squared plus 120 squared, so times 2, minus 2 times 120 times 120 times the cosine of 136. Okay, again, that's just an application of the cosine rule, and that gives me that chord is 222.52 blah 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 meters. And again, we just add those together to give the total length of the race. So the total distance is 692 meters. Again, that's to the nearest meter, and I've done that because the question has given this to the nearest metre. Arguably, it could be to the nearest 10 of metres, so 690 could be argued, but as part A was to the nearest metre, it perhaps makes sense to do 692. And when in doubt, 3 sig fig is good. Okay, question number 10. Find the range of values for k for which the line y equals kx intersects the circle with equation x minus 3 all squared plus y plus 7 all squared equals 8 at 2 distinct points. Okay, so I'm going to plug this through. So x minus 3 all squared plus y, but I'm going to say y is kx plus 7 all squared equals 8. Multiply it out, so that's x squared minus 6x plus 9 plus k squared x squared plus 14kx plus 49 minus 8 equals 0. So that's me multiplying out the brackets and bringing the 8 across to the other side. And I want this to be a quadratic in x, so I'm just going to factorise out all the coefficients. So I've got a 1 plus a k squared there. Okay, it's my coefficients of x squared. My coefficients of x, I've got a 14k and a minus 6. So that's going to be plus 14k minus 6x. And then my constant, well, I've got 9 plus 49 minus 8. So that's plus 50 equals 0. This is a quadratic, and this quadratic is going to represent the intersections of the line, the linear line, and the circle. And we want them to have two distinct points, two distinct points of intersection. So therefore, we require this quadratic to have 2 solutions. So for a quadratic to have 2 solutions, delta, or b squared minus 4ac, same thing, needs to be positive, strictly positive. So if you either write that or you use that, then you get a mark. In this case, our A is 1 plus k squared, our B is 14k minus 6, and our C is 50, because we're looking at it as a quadratic in x, and we want b squared minus 4ac to be positive. So that's going to give me 14k minus 6 all squared, so b squared, minus 4 times A, which is 1 plus k squared, times C, which is 50. I want that to be positive. This is now a quadratic in k squared. Okay, if I simplify that down, I'm going to get 196k squared minus 168k plus 36. Then I'm also going to get a minus 200 and a minus 200k squared. And I want that to be positive. Okay, 196 minus 200 is minus 4k squared. The minus 168k remains. And I've got 36 minus 200 is minus 164. I want that to be positive. Times it all by minus 1, or add everything across, I'm going to get 4k squared plus 168k plus 164 must be less than 0. Okay, I've times by minus 1, so that changes direction. I can divide by 4, so I get k squared plus 42k plus 41 is negative. And now I've got this quadratic inequality to solve. You can factorise it, you can sketch it, or you can use a quadratic formula. I get k plus 41, k plus 1 is negative. So if I were to draw the k-axis, something like that. This is my k-axis over here. And this is my delta axis here. Well, actually, it's minus delta, isn't it? Minus delta on 4. Either way, I'm looking for when this expression is negative, this quadratic is negative, and that's going to lie between the roots because it's a positive quadratic in k. So I'm looking between minus 41 and minus 1. Therefore, minus 41 is strictly less than k, is strictly less than minus 1, and that's my answer. And finally, I think this is the last one, question 11. Use the factor theorem to show that x minus 5 is a factor of that cubic expression. Notice that you must use the factor theorem. So you must plug in x is 5 and show that it equals 0. So we're going to get 2 times 125 plus 17 times 25 minus 65 times 5 minus 350. I'm just going to kind of break that down a little bit. That plus that actually comes to 675, and that minus that comes to minus 675. It just emphasises that it comes out to be 0. So because it's 0, x equals 5 is a factor, so by the factor theorem, x equals 5 is a root, therefore by the factor theorem, x minus 5 is a factor. Part B, hence fully factorise this cubic. Well, now that we know there's a factor, x minus 5 then must go into it perfectly. So we've got 2x cubed plus 17x squared minus 65x minus 350. You can use polynomial long division, which is what I'm going to show quickly now, but you don't have to. You could just jump straight to the answer. Okay, x times 2x squared is 2x cubed, so I want 2x squared up there, so it's 2x cubed. I'm going to get minus 10x squared, subtract the 2, that subtract that is 0, that subtract that is 27x squared. Careful because you're subtracting a negative. What times x gives you 27x squared? That's plus 27x. That times that is 27x squared. And that is minus 135x. Bring down the minus 65x, subtract the 2. Minus 65 minus 135 is positive 70x. Again, be careful, you're subtracting a negative. Which times by x to get to 70x, it's plus 70. Bring down the minus 350. Times that by that, I get 70x minus 350. That comes out to be 0, which is good because we expect there's no remainder because we know that x minus 5 is a factor. Okay, so we've pulled out the x minus 5 as a factor from this cubic, and that's left me with this quadratic, which means I can now factorise the quadratic. So I get x minus 5. Factorising this quadratic gives me 2x plus 7 and x plus 10. And that equals 0. And then it says, hence solve the cubic equation equals 0. So therefore, the 3 solutions are x equals 5, x equals minus 7 halves, and x equals minus 10. And that's it. That's the answer. Okay, I think that was the last one. I think there's 11 questions. Yes, great. Check out my other videos. I'll be going through the applied one next. And then I'll be doing the further maths ones as well for those students who are studying further maths. Thank you for watching. I hope you found it useful.